We are on the last portion of random variables. This video will discuss probability distributions for continuous random variables. Remember what a random variable is. It is a variable that has a finite amount of values attached to it. We talked a lot about discrete variables, and now we will talk about continuous variables. Remember the difference between discrete and continuous. Discrete variables are variables that can be counted, versus continuous variables are variables that can be measured. Okay? So think of time, weight, and things that can be measured. So, what is a probability distribution for continuous variables? Well, it's specified by a curve called a density curve, which I will show you in just a second. The most important thing to know is that there is a function that describes this curve. It's called the density function. It's usually denoted as f of x. The last and most important thing in why we study this is the probability impact of it. The probability of observing a value in a particular interval is the area under the curve and above a given interval. So, to find the probability of a continuous variable, we would need to know how to find the area under this curve. Now, before we do that, we have to make sure that we understand the properties of continuous probability distributions. These are some good notes that you should probably take. Okay? The first and most important thing is that f of x has to be greater than or equal to 0, meaning that every possible value has to be above the x-axis. The reason why it cannot dip below the x-axis is because we don't have any negative probability distributions. Probability can never be negative. Therefore, the area under the curve can never be negative. The second thing, in which makes finding the area under the curve actually really simple, is that the total area under the density curve equals 1 because, again, it is a probability distribution. Remember that the probability of any sample space has to equal 1. So the area under the curve here is already found. It is equal to 100%. So in order to find the area under the curve, we would actually need to have particular skills that are not fitted for this class. So we're going to start off with a pretty simple way of looking at this using geometry, something that everyone in here should be able to do. Here's the example. Let X denote the amount of gravel sold in tons during a randomly selected week at a particular sales facility. Suppose that the density curve has a height f of x above the x value where f of x is equal to this following linear equation, 2 times 1 minus x, when x is between 0 and 1. It's 0 under any other circumstance. So the density curve would look like this. It's a line segment. It's a linear function here, so it's a line segment. Now notice that the area under the curve has a particular shape. It's a triangle. So we are able to figure out any probable outcomes for this problem using the formula to find the area of a triangle, which is 1/2 base times height. Okay? Remember, all formulas are given to you in this class, so if you don't quite remember the formulas for geometric shapes, just know that you will be given them. So let's go through a couple of problems together here. What's the probability that exactly 1/2 ton of gravel is sold during a randomly selected week? So in our density curve, 1/2 is located between 0 and 1. Okay? So to define 1/2, we would just simply draw a line until we reach the curve. Notice that it's just a line, it doesn't have a particular shape. Therefore, this question isn't actually plausible for our problem. The probability would actually equal 0 because line segments do not have areas. Don't worry if you don't quite understand this. This is not important. The point I'm trying to make is you need to have an interval in order to solve these problems, okay? So let's review the second question here. What is the probability that less than 1/2 ton of gravel is sold during a randomly selected week? So since I'm talking about less than, I'm actually talking about the entire area to the left of 1/2, from 0 to 1/2. So now I have an area. I have a shape here too. and I should be able to figure out the probability that I will sell less than 1/2 ton of gravel in a given week. Much easier than finding exactly. So what we're going to do here, actually, notice this shape is a trapezoid, but I only gave you the area of a triangle. I could give you the area of a trapezoid, but that would just require a little bit more work. So we're actually going to use the complement rule. We're going to find the area of more than 1/2 because it's just simply a right triangle. Okay, so the height is 1 times the base of 1/2. I'll go back up just to demonstrate that. Okay, so the height of this triangle ends right there at 1, and the base is from 1/2 to 1. The difference is 1/2 there. So now I have the height, I have the base, and then I have to multiply it by 1/2 in order to complete the area of a triangle. So the area for more than 1/2 is, or the probability for more than 1/2 is actually a quarter. So remember what our complement rule says. The entire area under the curve has to equal to 1, right? So if more than is 1/4, that means this area less than is equal to 3/4. So the probability that less than 1/2 gravel is sold, so the probability that x is less than 1/2 is equal to 0.75 or 3/4. Okay, so again, the idea is that we are using the area under the curve in order to figure out the probability of a given interval. We only do problems with less than, greater than, at most, or at least. We do not do problems with exactly for continuous variables. Okay, suppose x is a continuous random variable defined as the amount of time in minutes taken by a clerk to process a certain type of application form. Suppose x has a probability distribution with a density function as follows. So f of x is equal to 0.5 when it's between 4 and 6. So given that f of x is just equal to a constant, this means that this is uniform, okay? And if it's uniform, that means that we just draw a line segment from 4 to 6. Pretty simple right there, okay? So let's finish this problem in this last example. What is the probability that it takes more than 5.5 minutes to process the application? So we need to look for 5.5, which is between 5 and 6. And then we need to draw the area under the curve. What kind of shape is this? Well, it's a quadrilateral. More specifically, it's a rectangle. So we use the area formula of base times height. The height goes from 0.5, so from 0 to 0.5. The base goes from 5.5 to 6. So, given that difference, the probability in which it takes more than 5.5 minutes, so the probability that x is greater than 5.5 minutes is equal to 25%, or 0.25, or 1/4. That's the end of this video. I hope that this was helpful. Please complete the assessment problems that are available online.